All right. Well, it's 8:35, so I guess it's time to get started. Thanks everybody for coming out to week one of Intro to Android Development. This week or this lecture, we'll just start off slow, go over some course logistics, give you guys a warm welcome, go over some basic logistics or basic sort of techniques with Kotlin and Jetpack Compose, which is the sort of framework that Android development is using in like the modern environment to make Android apps. And finally, we'll actually get into how to build some basic UI and to even show a demo for how you can start building stuff in Android. But starting off, definitely pretty slow for this first week. So just to get started with course logistics, welcome to Intro to Android. I'll be the first to welcome you, and thank you all again for coming out. We'll first start off by introducing ourselves. So I'm Justin and there's Amy. I'll introduce myself first. Well, yeah, my name is Justin. I am a CS senior in engineering. I guess I'm from Long Island, Westbury, New York. I don't know if that's important. Some fun facts about me is that I am a like home cook. I'm definitely not like an actual chef, but I like cooking. I have a wok and it's like super not convenient. I don't ever use it, but it's like cool to put on a resume like this, I guess. Let's see. Big EDM fan. Don't ask about the genres though, because you probably haven't heard of them. They're like really weird genres. I also DJ sometimes in my spare time. Big fan of cats. Yeah, I don't actually have a cat though. And finally, I used to be like a video game sweat, big like Counter-Strike guy, but those are like my old days, and we're past that now. And now I sometimes do like pixel artist stuff or game development, but it's not something that I've really dove like too deep into. But yeah, I'm Justin. Nice to meet you all. And next we can introduce Amy.
Hey, hi everyone. My name is Amy. I'm a sophomore in CS in Arts and Sciences, and I'm from West Lafayette, Indiana, go Midwest. Some fun facts. I'm currently learning how to gym and climbing. I'm a Java defender, but honestly, Kotlin is a pretty far language, so I'm really excited for you all to learn it. And some other things I enjoy doing, I'm in the chorale here, I play tennis, and I enjoy learning about more sustainability topics.
Okay, awesome. So now we'll just jump into some quick like course logistics, basically answer some like FAQ or whatever. So in terms of course schedule, all class times are at this time, 8:35 p.m. So lectures are on Mondays, so that's like today, which there is a Zoom option that we're currently like running right now, as well as YouTube recordings that we'll post after the fact. There are demos on Wednesdays, which is more of like a do-it-yourself, code-it-yourself kind of routine where we'll give you like a handout. You'll have some time to work through it yourself, and then we'll go through solutions for the sort of demo for that week. And I guess as a good incentive, anyways, to come to demos, these will be like pretty similar to or like very useful for assignments. And so therefore, if you come to demos and understand it pretty well, ask us a good amount of questions, then you should be pretty set for the assignments for that week. You can see the full schedule on our course textbook. There's a part of it, but it's on like the syllabus section. For some enrollment information, I think the ad deadline for this course is March 19th. You might have seen that the course application form technically already closed. So if you know anyone that is still planning to enroll, just make sure they email us at whatever courses at I forgot Cornell Active Courses at gmail.com. Or whatever, and it says it on the form as well. The drop deadline is April 9th, Wednesday, April 9th. Hopefully, you guys can talk to us as well if you're about to drop, and we'll remove you from the ed discussion about that. Speaking of ed discussion, in order to get help in this course, we'll have you mainly go through or make posts on a discussion or go to our weekly office hours. These are not being hosted this week since there's no assignment due this week. We'll get to that in a bit. But they will start up the 17th. So that's next week and going forward from there. And our course website has all like the textbook material and so on. And so from there, you should be able to access all of the assignment write-ups, all the slides, important links, and textbook material, and so on. In terms of the grading scheme, so that's technically A1 or A0, will not be graded, but apart from that, everything else has the grade breakdown here. I guess in a nutshell, assignments are 65%. Hack challenge is 20%, which is sort of like the final project for all active courses. And attendance is 15%. And not said here, I think it's said on the next slide, or it's coming up, but 70% is the passing sort of SU for this course. Um, in terms of the course structure, there's 6 weeks of sort of like dedicated lectures, five programming assignments plus one ungraded for this first week, as well as the Hack Challenge final project, which is the Hack Challenge is more or less a project for you to work with members of or students of other app dev courses. So that's like not iOS because we'll only have one type of front end, but you'll collaborate with backend students, design students in order to actually build an app for your portfolio, which is a really nice thing about our courses, which we'll get to in a second. And overall, yeah, project-based course, so no exams, which is hopefully good for in terms of stress and whatnot for you guys, since we would not want to give you exams. In terms of late policy, you'll have 6 total slip days and 2 maximum you can apply per assignment. A0, which is your first assignment for this week, is sort of ungraded. This is partially motivated by the fact that people end up adding the course late and have to go through like Android Studio setup and whatnot. And so A0 for the first week is ungraded, but then after that, you'll have sort of full-length homework assignments in some sense. And yeah, for attendance, attendance will be taken in a QR code form at the end of every lecture, Monday and Wednesday. 15% of your grade, a greater than or equal to 70% required to pass. Of course, we hope that you guys come and attend lecture and whatnot, but up to you. I guess if you run the numbers, you don't technically have to pass, but hope you still keep on coming. So just as a quick incentive for or a quick recap of what you'll get out of Intro to Android Development from the end of this course after you've finished it. First off, first and sort of foremost, hands-on industry experience. And so this means, or I guess the idea behind this first point is that we've actually restructured the course this semester, largely rewrote a lot of the material, or nearly all of the material, in fact, in order to align much more with industry practice. And so we've actually had a good amount of people on Cornell App Dev, like me, myself included, who have had industry experience in Android. That is an industry sort of Android software engineering job in Android. Learned all this sort of industry knowledge, all the secrets, and have brought them here to teach you them in the course. And so the idea, anyways, from this course is that if you take the material and understand it very well, you should theoretically be sort of ready to hop onto like an industry level code base and start working. A second thing is, as I said before, you'll have nice projects for your resume and portfolio if you choose to do Android development, which Android on the resume is like a super nice bonus. And I'll share some experience about that in a second. But because of the hack challenge that we'll have at the end of the semester, in which you build literally like your own app with a few other students, this is a great piece for your portfolio. You can put right on there and have a good talking point for interviews and whatnot. And finally, because Android is so accessible, like you can literally just download it and immediately start developing your own apps and even publishing them to the Play Store one day. All this course material allows you to continue developing Android for future projects if you would like to continue developing Android for your own personal sort of experience. As a quick note of what is sort of our anecdotal experience, Android is a really good job market. I'm not sure why this information isn't more publicly available, but to be honest, this is kind of weird because nobody talks about it, but in my anecdotal experience, I maybe should put like an asterisk next to that. Android is like a lot easier to get a job in than iOS in my experience. Because like nobody does Android. That sounds kind of strange, and I'm not sure why that is actually the case. But maybe like two things if you think about this is a little controversial, but like two things. Maybe if you think about it, people who are probably in software probably have like Apple products because they might be more like well off because that's unfortunately how the system might work. And so if they have an Apple product, they might just be more inclined to develop for iOS. But I forgot the second reason. But in any case, because Android is a much greater job market than iOS, having even just having Android on your resume or portfolio might indeed be a lot bigger of a benefit, or be a very great benefit because Android is hard to get to. And I guess as one final little piece of like anecdotal evidence, which I like to say, my brother is working at Meta for software engineering, and he was able to get an Android role at like Facebook Meta, uh, working on Instagram stories with literally zero Android experience on his resume because they just needed people to work on Android. And so if you imagine if you had Android on your resume, how much better of a bonus that would give for you, right? But enough of me yapping about that. Hopefully you are convinced that Android is a pretty good job market. Um, so let's see. So in terms of academic integrity, sort of like a thing we have to go over, unfortunately. Of course, internet's good. We encourage you in any software engineering projects in general to look up stuff and even use ChatGPT because it is a good tool. But plagiarism and copy pasting, and in some sense, copy pasting from ChatGPT is bad, and we don't want you to do that and have to set off any alarms. All assignments are individual, no collaboration until the hack challenge, in which you definitely have to collaborate. But yeah, hopefully Mr. Walker White's face enforces this a little bit more seriously. But yeah, any questions on course logistics, anything like that, before we move on to some content? Okay, yeah, cool. Next, we'll go into sort of a brief-ish introduction, like a surface level-ish introduction into Kotlin and Jetpack Compose, just to sort of get started. So we'll first start with some basic Kotlin fundamentals. So first off, we'll ask what is Kotlin? So this is the programming language we'll use in Android development. It's a language sort of built off of or derived from Java. I'm honestly not really sure how that even works, but nonetheless, it was in some form built off of Java. And so you could imagine that it's very similar to, slash has a lot of features that are shared from the Java programming language. And as of like sort of industry standard now, it is the preferred language for Android development, and unfortunately not many other things, but it is a really great tool, at least for Android development. And I wouldn't be surprised if it branches off to more sort of use cases from this going forward, because hopefully, anyways, you'll agree with me by the end of the course that Android is a really great programming language that is a best of both worlds between a lot of different programming languages. So it is sort of, in very quick summary, a blend between a simpler language like Python and a more robust language with a lot of features and sort of nice elegant development practices like Java. And so to give some examples of what I mean, we'll go over some key features of Kotlin that uh, tend to sometimes trip people up in the beginning. So first off, don't worry too much about the exact programming terminology since I know not all of you have a CS background. But nonetheless, if you're familiar with something like Python, you'll know that in Python you can do what is known as a programmer, anyways. You can do what's sort of depicted here in the first line, where you don't have to define any sort of data type. You just write that your name is equal to Leslie, the string, and it will imply that that is a string type or a string value. And on the bottom, if you're familiar with something more like Java, then you'll be more familiar with the idea that you have to explicitly type out the type of your variables. So this is what I mean that Kotlin, or by Kotlin being a sort of blend between Python and Java, where in the top, you can have this implicit type inference. The bottom, you can have the explicit type inference if you would need to, or if you would prefer it. And both of these are valid statements in Kotlin. And so every variable will end up having the static type. So if you were to go into like your IDE, like Android Studio, and roll over name, it would tell you that it's a string type. But you don't have to explicitly write that type in your code. So both these code snippets are valid and identical. And so in some sense, in the first line, even though you didn't type it as a string, it will know that it's supposed to be a string, which is, this is a good example. And we'll see a few more of how, again, Kotlin is a sort of nicer trade-off between I don't have to write all of these annoying things that I have to do in Java, but it still gives me that same functionality. Next up, we have, let's see, mutable and immutable variables. This is sort of just like a syntactic thing that you might get tripped up by. Every variable that you declare in Java has to be given this like val thing, which is a little bit more than you'd have to do with something like Python, but nonetheless, a val is sort of like an immutable variable, so you can't change it after assigning it. So if I say name equals Leslie, and then I try to reassign that or change the variable value to Ada, that is incorrect. That'll throw like a compiler error. But if I declare it now as var, I can now assign it to something else. So this is, I guess, somewhere more borrowed from something like Java, where you have to add some extra syntax in order to get your variable to sort of compile. And in general, you'll want to name things as a val until you explicitly have to change them at some point to a var if you want to end up reassigning it, just for like simplicity. But in any case, it doesn't really matter that much. For point three, this is a really nice feature about Kotlin that maybe you won't actually see too much benefit of in the beginning, but if you get sort of more into the weeds of development and software engineering in general, you'll come to appreciate a lot that Kotlin needs what is, I guess, known as explicit nullability. And so the data types here you'll see have we have sort of two of almost the exact same statement here. The first one is incorrect. The second one is syntactically correct. Where the second one, the only difference is this little question mark that indicates that a type can be allowed the value null. And so if you've developed in Java or well, I guess Java in the past, since this is like CS 2110-ish, if you develop in Java, you'll definitely be familiar with like null pointer exceptions and how annoying they are. And the idea is by making all variables have to explicitly be given the type null or like allowed the type null. There are a lot of cases where if you don't handle sort of like null exceptions, the compiler will actually catch that for you before you even start doing your code. And in some sense, then, if you are able to make your type not null, like sort of the first one, if you explicitly say this value will never be null, then it will never throw a null pointer exception, which is really useful if you can sort of ensure that in your code, which a lot of times you can. So yeah, of course, this makes null pointer exceptions a lot rarer and a lot easier to enforce code correctness without unintended bugs. And sort of the final point in Kotlin that is really nice and more, definitely a lot more pleasing than in Java is the idea of anonymous functions. So I believe looking at the course application form, most of you have taken CS 2110, or even if you have not, this is also like a relatively understandable topic. But if you have taken 2110, you'll probably remember how annoying it was to write anonymous functions and how like kind of funky that syntax was. In Kotlin, it's a lot simpler and just like a lot more visually pleasing, where the only thing you have to do in order to declare a function as or like an anonymous function is to have these little curly braces here. So literally just this sort of open brace, taking in an int parameter and closing brace defines an entire function. And so this is equivalent to saying like a more usual function syntax, like using fun keywords to then take in some parameters and use the curly braces here. These are sort of identical ways to define a function that will take in an int parameter and then do some stuff. And you can even make that have like a return value and whatnot. So anonymous functions are like super useful in Android development, as we'll come to see, since they're used chiefly in like UI components, but also things like click listeners for you to define what happens when you click a button, stuff like that. And so the fact that you can write an anonymous functions so easily in Kotlin comes to be very handy in developing UI. So yeah, that's it for in terms of Kotlin. At least that's everything we'll have for you in terms of lecture for Kotlin. We'll hope that you learn more about Kotlin with practice. So as sort of time goes on and as you work through the demos and whatnot, and ask a lot of questions to us, as well as the internet, as well as, I guess, ChatGPT, if you don't copy from it, you'll learn a lot more about Kotlin with practice and get familiar with it, as well with the code snippets that we end up giving you. So with that in mind, any questions about anything we went over there in Kotlin? Since I know that was kind of a lot of random stuff. Any questions? All right, cool. In that sense, or in that case, we can go over to Jetpack Compose. So to first establish what is Jetpack Compose. So Jetpack Compose is a sort of framework built on top of Kotlin and I guess Android Studio that allows you to build UI with functions. So that's why anonymous function syntax is super useful before. Kotlin is sort of the coding language, whereas Compose is the sort of library on top of it that allows you to build UI with Kotlin. So just some sort of clarification. So the way to turn a function into a UI component is this annotation here. So at composable, this is a sort of it's sort of like a modifier you put onto a function that turns a regular Kotlin function into a UI component. So this is like your regular function syntax that you would see in any other programming language. It's like oh, calculate score, returns an integer, and then you'll have your function. This is a composable that this is a composable function, aka a UI component, which sometimes we refer to as just a composable, that will display a UI component when it's called, essentially. And so in here, you'll have other UI syntax. You can call other composables, and then whenever you use iterate button in your code, it will render that component wherever you have called it in your screen or wherever else. So in order to build UI, we'll definitely leverage this app composable annotation. So the idea in terms of just building UI and building components, building eventually screens, is that you'll call these UI components, these composables within other composables in order to eventually build up and make a more complex UI component. So Compose gives you a lot of built-in UI components, many of which we'll go over in a little bit. But in this sort of eatery card example here, which is on eatery on the Play Store right now, you have these sort of inner composables. So as part of this bigger component, we have these inner composables, like a text here for bachelor house dining room. That is a text composable, which we'll go over in a bit, as well as another custom component we've had here, which lists allergy information, as well as a bunch of other them. You can probably see them generally as you break down this component. And the sort of outer composable, the complete composable that is made with this is this entire eatery card component. And then once you've built a UI component, you can reuse that UI component for any other like UI call later on in your screens. And so once we've built this UI, we've built this eatery card by calling whatever internal composables, then with this composable, we can use this eatery card component on like our home screen, for example. Yeah, on the main screen. Okay, yeah, so that's just a general idea with building UI, and we'll get into sort of the weeds of how to code that in Android Studio in a second. As a quick note, for Wednesday, we'll go over how to navigate Android Studio, as well as give more in-depth help as to how to navigate Android Studio. We decided to omit that section from lecture this semester because usually there's just not enough time. So make sure to please come to this demo Wednesday this week, since it is very crucial to know how to navigate Android Studio in order to complete future assignments, even though we don't have them this week. Okay, yeah. Any questions with any of that UI component stuff? Okay, yeah, cool. Hopefully it's all pretty simple. And so now we're going to go into how to specifically build stuff with some of the components that Jetpack Compose automatically provides for you. So here's sort of like the explanation for, or a bit of a generalization as to all of the Compose components that are given to you. All of the Compose components can generally be classified as like a container, so a UI component that holds or arranges other UI components in some way, or a view, a UI component that solely just shows some information or shows some picture or stuff. So I guess some components like service, which we'll see kind of do both. But in a nutshell, containers will sort of hold and arrange other views, whereas views will just display the actual content. So the more commonly used ones that you'll end up seeing are for containers are row, column, box, and surface, which we can go through one by one. So for row, column, box, and surface, pretty self-explanatory, although box will explain exactly what that means. Obviously, row arranges things in a row, column arranges things in a column, and box, what box does is allows you to sort of dynamically layer things on top of one another. So, for example, in this box, I could layer this first view in the center it. I can have one on top, or I can have that view on top of two other ones in the background that are sort of being rendered underneath. And so while a column and row are very separate, each view is supposed to be separately viewable. In a box, you can layer things on top of one another. And for surface. Uh, this is what you'll actually do in your demo for Wednesday. But you can see this surface allows you to make sort of like a shape that has a couple of different ways you can customize that shape. And so you can generally see that this entire surface here contains this other composable content, which, if you might guess, might be broken down by like a column and so forth. Uh, but yeah, you can see here then that the surface kind of is both a container interviews in that it shows this card content as well as containing other content as well. Other containers will sort of go into more as we get into the course, and some of them will get kind of complex, requiring state, which we'll go into next week, such as a lazy call. In terms of views, again, these are pretty basic stuff. All these are relatively self-explanatory. We have text, so text will display text, and there's a lot of ways you can customize that text. Icon displays. Icons display little well, certainly icons that are imported into Android Studio with like a specific file format. If we end up going through that, we'll just give you the files. But you typically get this from like your design team. Image can display like an actual, much more conventional PNG image or other data that you get, or other images that you pull like from the internet, for example. Buttons give you sort of like an on-click feedback as well, which we'll get into, I think, probably get into next week when we get into more of like states and listening to events from the user, as well as some more complex views, which we'll get into much more next week. Okay, yeah. So one thing in terms of like UI development and Android in general is a lot of very nitpicky sort of uh, detailed editing of like the fine details of every view or component. So one question, for example, is how do you make this left text here versus this right text? So if your design team gives you, oh, I want to make this left text as opposed to this right text, how do you actually determine that in your code? So for fine-grained changes for every UI component, especially the ones that are given to you by like Jetpack Compose, the ones that are built in, you'll want to look at the arguments for the composable, since if you remember, every composable is a function, and so therefore that function can take in a lot of arguments. And so you'll want to pass in the correct arguments to make that text or whatever component render how you want to. So in this case, you would pass in stuff like font size because it's larger font weight, and also like the different actual font family because it is not the same font. And text alignment, for example, will make this centered as opposed to left aligned. So all of those things are arguments you can pass into the text composable in order to make it render the correct way. Next, we'll go into modifiers. So this is another way to turn your give your components a sort of like fine-grained differences, or to add fine-grained differences to each component. So how do you make this text on the left here, which is contained by this like box here, or exists within those boundaries, versus this one, which sort of spans the entire screen width. So for more general changes to how a view renders, so you can imagine that if I made this like an icon, a text, all those same things would apply. How do I make it stretch the entire way? For a more general change to how a view renders, you'll want to use a modifier. So that's for stuff like width, height, background color that can really generalize to any component. So here, for example, technically not the best example, but if you apply this, or if you apply to this text a fill max width modifier, it will take that container and sort of, or it will take the bounds of that component and make it span the entire screen, versus a dot width modifier, which you can explicitly say, oh, for example, I want that box to be 100 pixels wide, more or less. There are a lot of modifiers, and they are definitely very useful. So, for example, fill max width, fill max height are pretty self-explanatory. Or not self-explanatory, but they were what we saw on this slide here, with it spanning the entire either width or height. Background gives a background color. Padding gives a little bit of space around it. So if you've ever worked with front end frameworks, you'll generally hear the word padding as to just mean sort of space, create space in or around that component. Width and height, which will hard code the dimensions, as well as clickable, which actually give you the ability to make any component sort of clickable, and to give allow the user to like click a button and then you can just define like behavior for what happens when that button or component is clicked. All of these allow you to give like sort of finishing touches and like very specific shape to your UI that's been given to you or the UI that you have to create. And we'll learn most of these modifiers hopefully by example or demo, since there are definitely a lot, and it's more than we could sort of just cover in a lecture format. Um, and certainly we would hope that if not by example or demo, that you'd be able to find these things also on the internet or just by asking ChatGPT because it's pretty good at Android UI stuff, surprisingly. But yeah, any questions about any of that stuff? So a little bit more intricate UI stuff. Any questions? Okay, in that case, we'll get into a demo in a little bit, but before Wednesday, do not have to do this now since in terms of lecture demo, I'll just be demoing it on my end. But before Wednesday, I will want you to download Android Studio. So you should just be able to do that on this link here, developer.android.com/studio. But yeah, before Wednesday, since in demo, we'll want you all working with us sort of hands-on with the demo that we've provided. We'll make sure to do this before class on Wednesday, but no need to do this now. But if you'd like to, that's also fine. Okay, yeah, so now we'll go into a brief demo about kind of just basic UI and building a basic UI component, which I will take a second to transition to in Android Studio. I need to reshare my screen. It's unfortunate. Okay. So anything that you see here, any code that you see here is available on the course textbook. In fact, we can just quickly show where that is. So in week 1, relevant links, you'll be able to see the lecture demo link right here. It's just a GitHub link, and you can follow the instructions there to download all of that onto your machine and open it up in Android Studio. So there are the lecture demos that we'll give our broken down into each lecture. So this is week 1. We'll just go into lecture 1. And this lecture in particular happens to be a sort of to-do walkthrough demo that we will work with right now. And so, yeah, no need to pull this up. And this is all hopefully being recorded and posted to YouTube afterwards. So all of this you can take a look at later. But here we will go over building like a very, very basic UI component and just going through how to access and sort of work through the specific arguments that we have in order to build a component that looks better than what we have right now. So very quickly, just breaking down what we have a component here called expense row that's more or less going to display some information about an expense we just made. It takes in a title, which is a string, a date, which is also just a string, as well as an amount that either sort of went up or down. And the idea is that if the amount is negative, it'll be displayed here in text in red. If it's positive, it'll be in green. And so we have, let's see, a good amount of work to do since this component here looks kind of trash. You can't even really even see it because it is on a like transparent background. So you can generally though see here that we have the groceries, which is the sort of title, the date underneath it, as well as the amount to the right. And going through at least what we have now, the way that we've arranged it, you can generally see the format that everything here is contained within a row, where this column here, sort of all the left content is one element in that row. So that's this column here that contains the other 2 texts. And then the other element in that row that's horizontally next to it is the other amount text here. So this amount text is basically just calculating, it's kind of just turning like a 2.0 into a $ 2.00. So no worries about that. That's just some like weird Kotlin stuff, but just to make it look nice. But you have this text here that will show the amount as like a nice $100.00 here. And you can always add these little if statements in your Kotlin code as like a sort of conditional. So we're just saying in line here, if the amount is sort of less than 0 to indicate that we've lost money, we'll just make the color red, and otherwise we'll make the color green. If you're wondering how this preview sort of rendering is happening, it's down here in this preview function. So we'll go over this on Wednesday, basically how to write one of these yourself. But very basically, this preview function is a really nice way for you to, in like just within Android Studio, open up a little preview to see what you're building, and one that will update automatically as you are building your component. So here we just have a preview for expense row. And you can see here all the information matches up. Groceries, that's why it says groceries, date, year 2022, I guess, and the amount up there. So for example, if I were to change this to -100, the preview will compile, build, blah, blah, blah. Hopefully it doesn't have to rebuild. But once it finishes previewing, you'll see here that the preview there, again, automatically updates. So now we have -100. And as well, if I change any other components here, or if I can change any other data here in the preview, it will automatically update after the build has completed. Okay, so what's more important is that in your preview, once you make changes to your actual component, like your actual code, it will automatically update in the preview, which is really nice. So I've listed out a couple of to-dos here for myself that will walk through how to go through some fine-grained changes and use modifiers and arguments to change your code. So as I knock out these to-dos, you'll see that the preview just automatically updates and I don't have to rerun anything, which is super nice. So first thing, first little to-do I've made for myself is to make the background white. So the way I'll do that is with a background modifier. And the idea is a modifier can be really much or really applied to any component. So if I roll over this text here, you'll see as one of the arguments I can apply a modifier. If I roll over the column, I can also apply a modifier. If I roll over the entire row, that's everything containing this, it can also take in a modifier. So every component in Compose that's at least given to you automatically can take in a modifier. And so if I want the entire container to have an all white background, I will just apply it to the row since it's the container containing everything. So I'll pass in a modifier here, and that modifier will have the background white. You'll have to import this every time, which is really annoying. Make sure you import the right one. In doubt, do the one that says compose. And then you might have to import some other stuff automatically, but let's see what that looks like. So now I've applied a white background modifier, and now you can see that the component at least has a white background, so we can see it pretty well now. So I guess we can knock that out for now. Next, I suppose one thing to also look at, for example, before we move on is, what happens if I, for example, put this on the column? Well, because every component can take in a modifier, this will only apply that modifier to the column itself. So you can see here that this is the bounds of the column on the left versus the other element in the row. We've only applied the modifier to that column. So if we do it like this, the background would only be white in this area because that's the column as opposed to the entire row. So let's make sure to put that on the row instead. And so next we can take a look at this next to do, make the title text. So I guess that's the grocery text, bold and larger. So in order to do that, that seems like a very specific thing to the text component. So that won't be a modifier per se. That'll much more go into the text argument, the argument that you pass into the text composable. And so you can see here, well, all of these are kind of annoying to read, but in any sense, the bold is font weight. So we'll let that autocomplete. And you can pass in something like font weight dot bold in order to make the text bold. So if we just look at that for starts, you can see that now the grocery text is more bold than the text beneath it, and larger, that will be a font size. And oops, I've autocomplete on. Let me turn that off. Yeah, I don't want AI writing this code for me. If I want the font size to be larger, I'll pass in something, or I'll pass in the font size argument, which is again specific to the text component, and I'll pass in something larger. Well, I guess I'll say 24. I'm not sure what the default is, but nonetheless, that should be, yeah, substantially larger. So now we have the grocery text is a lot larger. So this is starting to look like a little bit of a better component. So we'll knock that off. Next, we should try to make everything sort of vertically centered. So you can see here that this component here on the right, the text here, is the other part of that row, as we were saying before, but it's a little stuck to the top, whereas you would imagine if we wanted this to look nice, maybe we'd want this instead to be vertically centered here. So um, sometimes this, depending on what the sort of outer container you're using, sometimes this will be a modifier job versus a argument job. But because we're using a row here, if we roll over row, you can see here that one of the arguments you can pass into row is a vertical alignment. And so this right here, the default you can see is alignment.top, which makes sense because the amount text you can see here is sort of glued to the top. But if we change that instead, then to vertical alignment equals something like center vertically. So vertical alignment equals alignment.center vertically. Then that would change the text there on the right to now be centered vertically. All of these sorts of things, the specific values you'll pass in here. Again, I only know that because I've written that line probably like 100 times. But specific lines like that, you'll probably want to sort of look online to see what specific values you want to pass in. Or you can like also ask ChatGPT. You'll definitely be able to answer that. In any case, this is still good practice to see like, oh, if I want to change something, where do I look? Do I look towards a modifier, arguments? What do I change? So nonetheless, that's pretty good. So next, we want the row to take up the entire full width. So you can see here that everything's pretty scrunched up, and there's no sort of space in between here. You can imagine that if you open this on a phone, you'd want this to span the entire screen, have this sort of anchored onto the left, and this 100 anchored all the way to the right. So we can do that first by another modifier. And something that's nice about modifiers is that you don't have to like sort of keep calling modifier dot, modifier dot. You can just chain them. And the order of the modifier matters in specific circumstances, but not very many. So for example, if I do dot fill next width, and we'll just stick with that for now, you can now see that the preview takes up a lot more sort of horizontal space here, right? Obviously not great still, since the text here is anchored still towards the very left. But at least now the row is taking up the entire space. And so, again, that seems like a property that's kind of specific to the row, since if I were to define a row as a coder, maybe I'd want it to stick here. Maybe I'd want the row instead to have a lot of space in between. Maybe I want to space them evenly throughout. And so if I look at the row argument here, I can see that one of the other arguments is horizontal arrangement equals start is the default value. So that's why it's sort of making everything glue to the start, or I guess in this case, the left of the row, because we were passing in start as the default value. But if instead we therefore change that to, I think it's, let's see, arrangement dot space between, or no, space, maybe it's that. Let me see. Should be space between. Yeah. If we change that to space between, what that more or less does is if we were to have like several elements, it would put in as much space as it can between each element. And so because we only have two elements here, it'll put sort of all of this space in between and push this all the way to the right. Another way we could do this is with like a modifier. So just to show, you would only have to do one of these. You could add this other component here called a spacer, or really like any like empty container that doesn't actually like show anything. And we can like, this is more or less the same solution where you put a modifier dot weight on there. And what the weight does is try to take up as much space as it can in that container. And so you'll see here that there's this sort of invisible spacer here now between the column and the text. This spacer, because no other things have a weight modifier, it'll just default to trying to take up as much space as possible. And so now that pushes all the stuff to the left all the way to the left and the right all the way to the right. So similar solution, but either one is fine. I guess we'll just stick with this. So now make the row take up the full width. That seems good. And so now finally, for this last bullet, at least that I've made for myself, we can add some padding to make it look a little nice. Since specifically in the preview here, this might be a little small. Let me try to zoom in a bit. You can see here that the text here on the right and as well as like on the left are very much just exactly hugging the boundaries of the component. And if you were to render this on an actual screen, on an actual phone, that wouldn't look too great, right? Since it would be hitting literally like the very edges of your phone. And so in general, adding like padding around your component is how you make that look nicer. And so again, I can just chain like another modifier here and add some padding. So for example, something like HDP. A DP is kind of just like a unit of measurement. It's kind of like a pixel if you want to think about it like that. Then you can now see all the space that's created. And if I were to even increase that further to something like 16, then the preview will auto render and give me even more space, although I'm not sure if I'd want that. But maybe something like that looks pretty good. So that is sort of like our completed component here. I guess since we have a little bit more time, I can do sort of one more final thing. Let's say I wanted to do something a little bit more complex that takes a little bit more logic and to make this component more intricate. Actually, just before I do that, I can show you that in the preview. You can really make this preview anything you want. So I happen to only call that expense row once, but let's say I wanted to call that a couple more times. I could very much do that. So in the preview here, I just want to, as a developer, see now 3 expense rows if I wanted to debug like that. Now we'll have 3 expense rows since I put them in a column. Um, so let's say, for example, that one of them is like plus 100. Then you'll see here that this text here will go to plus 100. And let's say this bottom one here, what if we added a condition that's like, oh, if I passed in 0.0, then I wouldn't want to show the text at all. So this is a little strange, right? Plus 0.0. I probably just wouldn't want to show this if there was no change in transaction, right? So let's say we wanted to implement that, make it so that if the amount is 0, then we just do not render this text altogether. Well, that's something we can do very quickly here. Oh yeah, you can also show and hide the preview with these little buttons here, but again, we'll go over that stuff on Wednesday. So I guess the sort of task for us now is if the amount is 0, we want to sort of hide this, or alternatively, or I guess the alternative way to word that is if the amount is anything but 0, we will want to show this. So that is very easy to do with like conditional rendering, which I'm pretty sure we'll get into next week. And that is like with Kotlin, this stuff is super easy to do. And something like React, this is terrible to write. But in Kotlin, this is really easy. You just write sort of if amount is not equal to 0, then you render the text. There might be some, yeah. Amount currently is a double, so we'll just put 0.0, I guess. Usually you'd use a float value, but it's not really that big of a deal. But now you can see here that, yeah, if the amount is not 0, these texts are still showing. But because we've passed in 0 to this bottom one here, now because of this if statement, the amount is 0. Therefore, the content within this if statement will not fire. And so therefore, this function call will no longer happen, aka meaning that this component, this text, will no longer render. So the fact that you can write all of this just so easily very much comes from the fact that all of these components under the hood are just functions, right? And so if you conditionally call the component, or if you conditionally call the component, then you're either just calling that function or not. And so if it's not that, it will just not execute this and therefore not show the text. So that's just another random thing you could add. I could keep showing you stuff, but you'll get hands-on experience with this as we go on. Any questions about anything we just did then? Yes.
Notice that like you mentioned that DP was like kind of like a pixel value. What about like SP and the font size?
Good question. SP, I'm not actually sure exactly what it stands for, but SP, it is a very similar unit of measurement for font sizes in particular, or like sort of text sizes in particular, anything that has to do with text. The idea with DP and SP is that regardless of what device you are developing on, it will render those components the exact same way. And so you can imagine that even though technically like different devices will have different number of pixels from screen width and screen height, and like a different amount of pixel density, the DP will automatically under the hood like compute that for you and show the right information. And same thing for SP. Regardless of sort of how many pixels that actually needs to be in terms of height or width for each font, the SP will sort of, that unit will sort of count that for you and or account for that for you.
Thank you.
Okay, other questions? Yes.
It's
Oh.
up for you. What is it?
Oh, yeah, sure. We'll get to everyone.
How can you define parameters for the road type?
Yes.
If you wanted to make it explicitly nullable, would you just put the question mark at the end?
Oh, yeah, good question. So, absolutely. So the question is basically, if you wanted to make a parameter nullable, can we just add the question mark, which is very much a yes. So if, for example, I wanted to change this component to say, oh, instead of passing in 0, I wanted to check for null if I wanted to just not show this component, then I could make this nullable. So add a little question mark here. And I can even make this have a default value, for example, of null. And so what that will do is that if I don't pass in an amount, it'll just default to null. And so let's see where that broke some things. Let's just say this broke some things. This is not too important. Don't worry about this. Let's see. And just to get this to compile, let's say instead that we wanted to make this check for null instead of 0. And then finally, we could just not pass in a 0 here. And then the same thing happens. So basically, this is now defaulting to given a null value as the argument value. And because now we're checking that the amount is null instead of 0, this final one here will still not render the 0. So absolutely, just like you can define any variable name or any variable type as nullable by adding that question mark, you can very much do that same thing with function arguments or function parameters by adding that question mark as well. Yeah, other questions? Yes.
If you had put the like vertical alignment only on column or the text that is for the price, would it still work?
Let's see. So yeah, the question is this vertical alignment here, if we only put it on the price text, what would happen? The idea is with the vertical alignment, the idea is with vertical alignment is that it's a property of the row. And so if you see here, or if you go into like the text arguments, or if I try to copy this over, this actually won't be something that text is allowed to take in. So now you can see that text is throwing an error, basically saying that the vertical alignment here isn't something that it's allowed to take in. And so the idea is with vertical alignment that that's a property of the row container, since the row container is responsible for managing how the elements within are vertically arranged. And therefore, that is a property that's only applicable to the row and not to the text. So in fact, you would not be able to apply that to the text. And that's only something that the row can manage or care about, if that makes sense. Good question, though. If anyone has any more questions, you can come up and talk after lecture since our time is up. But before I forget, in terms of a brief attendance form, we'll have you fill out a QR code like this at the end of every lecture. Let me know if you can actually open it and see it correctly. If I didn't mess up, you should be able to. This also doubles as a way for you to give us some feedback. So if there is some course content that was a little confusing for you, you can also indicate that very briefly on that form. But it also helps us just keep track of your attendance. But yeah, if you have any other questions, feel free to ask us after lecture. We'll stick behind for a little bit. But apart from that, that is all we have for you. So thank you very much for coming out to the first lecture, and we'll hope to see you on Wednesday. Make sure to download Android Studio.